One of NMN's most persistent marketing claims involves mitochondrial ND+, the argument that NMN uniquely or preferentially boosts ND+ levels within mitochondria, rather than just in blood or cytoplasm. This is presented as a key advantage for cellular energy production because mitochondria are where most ADP synthesis occurs. If true, it would represent a meaningful functional distinction. The problem is that the evidence supporting this claim in humans is thin, often derived from cell culture or animal models, and not validated against comparable delivery methods for older precursors. Meanwhile, niacin's mitochondrial effects have received comparatively little research attention, not because they don't exist, but because niacin has been around long enough that its basic biochemistry was characterized before mitochondrial ND+ measurement was technically routine. Understudied is not the same as absent. The assumption that niacin fails to elevate mitochondrial ND+, while NMN succeeds, is not supported by direct comparative human data. It's an inference from theoretical pathway pharmacology and a handful of non-human studies. This opens a genuinely interesting practical question. Could formulation improvements to niacin bridge any real or theoretical gap in cellular delivery? Liposomal delivery encapsulates compounds in lipid vesicles that may improve cellular uptake and bypass some of the enzymatic degradation that occurs with standard oral administration. Sublingual administration bypasses first-pass hepatic metabolism entirely, delivering the compound directly to systemic circulation. Extended-release formulations sustain plasma levels across longer windows, potentially providing more consistent cellular availability. None of these approaches are NMN-specific. The honest self-experimentation protocol for anyone genuinely curious about this would involve comparative tracking across formulation types. Standard oral niacin establishes a baseline. Liposomal niacin tests enhanced cellular delivery. Sublingual nicotinamide tests bypass of hepatic metabolism. Each trial period, 4 weeks minimum, should use consistent objective metrics, subjective energy ratings, exercise recovery times, performance markers on standardized tasks. The question you're answering is whether formulation changes in niacin territory close the gap with NMN's claimed cellular advantages, and at what cost premium. The cost-effectiveness framing matters here. If liposomal niacin provides meaningfully better outcomes than standard niacin and costs 3 to 5 times more, that's still substantially cheaper than NMN and deserves consideration for people who have found standard niacin insufficient. If the outcomes are equivalent, you've identified the optimal cost-effectiveness point. The point is that NMN versus niacin isn't the only frame available. Formulation science applied to niacin creates a range of options whose cellular delivery hasn't been seriously characterized against NMN in controlled human trials, which means the comparison is currently incomplete in ways that favor whoever has the better marketing.